All right, this is video 1 for 4-2. You should be on the second page of notes, or rather the third page front. It starts out 4-2, points of concurrency, perpendicular bisectors, and the circumcenter. We are talking about circumcenters and incenters, and how they help us determine congruency of various parts of the triangle based on their definitions. So let's get started. That first bullet point, we're talking about how many perpendicular bisectors can you have in one triangle. You can have 3 perpendicular bisectors in one triangle, one for each side, because each side can only have one perpendicular bisector. So the 3 perpendicular bisectors together have one point in common. There's one point where they all intersect. That's a point of concurrency, and that is called the circumcenter. Okay? When we draw the 3 perpendicular bisectors, for the 3 sides of a triangle, the point where they all intersect is called the circumcenter. The circumcenter is the center of the circle that circumscribes the triangle. That's why it's called the circumcenter, because it is the center of the circle that circumscribes the triangle. A circle is said to circumscribe a triangle when it intersects all 3 vertices of the triangle. So if we draw a circle that contains all the points, all the vertices of a triangle, that is the circle that is circumscribed. It is around our triangle, and the center of that circle is also the circumcenter of the triangle. The circumcenter is equidistant from the vertices of the triangle. If we draw out these lines from the vertices to the circumcenter, those distances are all going to be the same. They are all congruent. They are all equal. The circumcenter is equidistant from each of the vertices. Equidistant means same distance. Great. So take a second, pause the video if you need to, and try to write what the circumcenter is in your own words. Think about how it's made, how does it relate to the triangle, write that down, and come back. Okay, thinking about what we just covered and this figure, why can we say that the circumcenter is equidistant from the vertices of the triangle? Well, the first thing is that any point on a perpendicular bisector is equidistant from the endpoints of the bisected segment, meaning that if we just look at this perpendicular bisector, just this one for this side, any point on this line is going to be an equal distance from this point and this point. Okay, so we know that any point on this line is equidistant from those 2 points. We also know that any point on this line is equidistant from these 2 points, these 2 vertices. This one, the same thing. Any point on this perpendicular bisector is an equal distance from these 2 points. So at the point that they all intersect, we now have a point that is on this perpendicular bisector, so it's equidistant from these 2 vertices. We have a point that is on this perpendicular bisector, so it's equidistant from these 2 vertices. And we've got a point on this perpendicular bisector so that it's equal distances from these 2 vertices. It's equidistant from all 3 vertices. Because this point, the circumcenter, is the intersection of all 3 sides perpendicular bisectors, we know that it's equidistant from the vertices of the triangle. Okay, so looking at this figure down at the bottom right, we're given that point P is the circumcenter of triangle EMK. So that is the point where all the perpendicular bisectors intersect, which also tells us that all of these arrays that are being drawn out are the perpendicular bisectors. So if we know that, then we can say that MY is congruent to YE or EY, because this is a perpendicular bisector, then it's cutting this side in half. We can also say that KP is equidistant, MYE. KP is going to be equidistant, and it's not going to be equidistant, it's going to be equal to, it's going to be congruent to MP and EP. Because remember, this is our circumcenter, so if we're talking about this line segment, that's the distance from the circumcenter to the vertex. So all of those distances are going to be the same. All of those line segments are going to be congruent. For MN, we know that NK is going to be congruent. EN is the bisector of MK, so it cuts those two lines in half. It cuts that individual line in half into equal pieces. And ER is going to be congruent to RK. ER and RK are going to be congruent because MR is a perpendicular bisector of EK. That's the end of the first page. Go to the next video for the next page of notes. Okay, thanks.